Whether you are shuffling a deck of cards or holding your breath, magic is pretty simple. It comes down to training, practice, and experimentation, followed up by ridiculous pursuit and relentless perseverance. With these words of David Bain, I would like to welcome our esteemed guest and the audience to the first virtual exhibition of Kshitij 2022. Good morning, everyone. I am Anil Jyoti, co-organizing team member of Kshitij 2022. Today's evening, we are honored to exhibit the prosthetic leg and the technology involved behind it by Rise Legs. Rise Leg is a Bengaluru-based startup started by Mr. Arun Cherian in the October 2015, and since then, it produces prosthetic leg for amputees out of Kenya. Moreover, the product can be customized based on the purpose as well as the appearance. Rise Leg aims to improve the quality of life of the person who needs a prosthetic leg. So now I would like to introduce you guys to Mr. Arun Cherian. Mr. Arun is the founder and the CEO of Rise Legs. He has done his Bachelor of Engineering degrees in Mechanical Engineering from Anna University, Chennai. He has done his Master in Science in Mechanical Engineering from Columbia Engineering College, New York. He was a research scholar in a human engineering lab at University of California, Berkeley. He was an innovation consultant at ICRC Bengaluru, Karnataka. Also, Mr. Cherian was a D Labs Scale-Up Fellow at Massachusetts Institute of Technology, Cambridge, United States. We also have Q&A session dedicated for any sort of questions you may have at the end of presentation. So without further delay, let's move to the presentation. And from here, I would invite Mr. Arun to make the presentation successful. Hello? Hello, sir?
Yes, can you hear me and see me?
Yes, sir. We can hear you and see.
Wonderful. So, hello everyone. My name is Arun Cherian. Anil, thank you so much for the kind introduction. And ladies and gentlemen, it is my privilege and honor to be on this platform and share with you our journey in making a health tech company that makes wearable bionics affordable and accessible to people. So without much ado, let me just open the presentation and, let's just take it from there. Okay, so let's see. Can I have confirmation? Can you see my share screen?
Yes, sir.
Let me make sure that the system audio is also there. Yeah. Wonderful. Yeah, so here at Rise, our goal is to make wearable bionics affordable and accessible to people, not just in India, but Asia, Africa, and South America. And that being said, it's not about just making it affordable, but also it should be great. Now, let me just start off with the story of this little girl by the name Samira. She was born without both legs. And very quickly, it became a challenge for her parents to give her the appropriate devices for her growing needs, just so that she could have a normal life. It would either be too expensive or just beyond their reach, physical reach, because they would have to travel much to get her fitted with these devices. Now, when we started, when we started our journey, there was some interest and publications in the media about the stories that I will be telling you later on. And Samira's dad friend heard about our work, told her dad. Such was the need for devices for her that her dad, this is before we even had a website, such was the need, her dad went to the local studio, inquired about this video clip, they directed him to the local reporter across the state here in Karnataka, told them about, so he connected with the local reporter. The local reporter then gave him my number. He then connected with me, and it's been about 5 years that Samira and her parents have been coming to us and getting fitted with the devices that now Samira not just goes to school, she runs, plays and dances. She's in fact entered a dance competition in TV about, a dance competition, and she is well on her way to have a rich, normal childhood. Now, the story of Samira is only just one among many people, not just here in India, but across the world. Like in India alone, just when it comes to prosthetic legs, there are significantly over 1 million amputees in India alone. The largest cause of amputation is not war or road accidents, but it's diabetes. And realistically, on the ground, people say the number on the field is actually 2 to 3 times that. Now, world over, there are significantly over 7 million amputees, significantly. And when it comes to other forms of disabilities too, because we no more just make prosthetic legs, but we do it for the entire body, from the head, spine, hand, and leg. It is well over 15% of the population, according to WHO, that need some form of assistive devices. And with the population of over 1 billion, this is like a significant size. So now, one of the challenges that we've observed is that there isn't much options available to people. It's either low cost and heavy, that is possibly even given out for free, or the other option is these are these expensive devices that are lightweight and flexible and performance oriented, but out of the reach of far many people, because it starts in the lakhs. In the lakhs, these devices start. So our goal was to use technology to make these devices affordable and accessible. And I am a robotics engineer by training. So I studied the biomechanics of locomotion. I was doing my PhD. So I'm a mechanical engineer through and through, bachelor's, master's. I was doing my PhD, and then I dropped out of my PhD to do this full time. So having studied the biomechanics of locomotion on how animals and robots can walk and run, there was this very niche insight that, you see, whether it's an elephant, giraffe, lion, human, a mouse or a cockroach, doesn't matter what the mass of the weight of the animal, or even the size of the animal, or whether it is like whether they have over 100 legs like a centipede, 8, 6, 4, or 2 legs. It doesn't matter. The leg spring stiffness to body weight ratio for all animals is effectively the same. So now, effectively, the human leg, or the leg of any animal, is a spring of tuned stiffness. That is a deep insight that I learned through my journey in the biomechanics of locomotion. Now, having come to India, you have these cane furniture, especially with those of you from the south know, you have a lot of these cane furniture that's bent in all these beautiful shapes with which you can sit, and it will last. It'll last for decades. Now, if this system can take weight and is flexible, that's a spring in itself. So for me, it was a curiosity-based question. That is, if the human leg is a spring, and now you have this cane furniture, the cane that is a spring, it was a curiosity-based question. Could I make a leg out of cane? It was a curiosity-based question. So I went to the aerospace department after a lot of testing. I, in fact, went to ISRO, and then I ended up at one of the scientist professor's place in the Indian Institute of Science at the aerospace department at Professor M.R. Butt's lab, wherein they do non-destructive testing for fibers. And cane is a natural fiber, wherein carbon fiber is an engineered fiber. cane is a natural fiber, and because it's a composite, it's highly non-linear. So there is so much of simulation one can do, FEA simulation. At the end of the day, you just have to test it in a machine that's big enough. So, I went to the aerospace department in ISC and then tested it for a fact, and I knew that it was strong enough. Again, there are 1,200 different species of cane with which you can make these devices, but I use this one particular species talking to local artisans. Again, please understand, I'm a robotics engineer by training. I have no background when it comes to wood, cane, or let alone even wearable medical devices. It's about talking to the right people that are just way smarter than me that I was able to figure this out. In fact, I went to the local artisan when I came down to India and asked him, can you bend cane in about the shape of the human leg, like you see in the far right, like a J-shaped leg? He's like, sure. And I was like, can you make it the size of the human leg? He's like, sure. I was like, can you make it strong enough that it can take the human weight and more? He's like, sure. I was like, oh, okay. And then we made a prototype, and of course, out of 1,200 different species, he recommended, you know what, you should try these using artisanal local wisdom. We quickly brought the selection down to a few species of cane and then tested it, and it worked far better than I expected. Just to make a point that affordable or accessible technology need not be compromised in its performance, we went to Zurich, Switzerland, competed with the world's best. This is a German company that came in with a 50 lakh prosthetic leg. We were the only team from India that got selected. Ours was less than a lakh. This is the Ferrari of prosthetics. They came in with a 70 lakh prosthetic leg dollar conversion. In India, it's more than a crore, one leg. In fact, this is a Japanese team with an experimental device. Now, out of the three obstacle races, not only did we come first in the three races, we also fair and square clocked in the fastest lap time. Fair and square with devices that cost orders of magnitude more than ours was. So this is to show that with deep insight, you can make disruptive technology that is good and great at what it does. Now, not only is it just functional, wherein people go like, this, you can walk with this, but we wanted people to run, play, and dance. And, there is a whole emotive facet to technology and the tools that we developed, that we wanted it to not just be perceived as a medical device, but more of an extension of their body, physically and emotionally too, that we and then also we also cleared with the Indian Army. This is an officer walking with our prosthetic leg. You can see he's walking with an almost perfect gait. So now also, just so that it's an emotive extension to one's body, we created prosthetic legs that are just think of it like a full body tattoo. It can be an art expression, so on and so forth. And we built a real community of patients and customers who not only are able to get back to life, but then they also help each other out, wherein they thought that they couldn't, Again, these are just two people like you and me, perfectly normal, for no fault of their own. They are in an auto, blackout, wake up on a hospital bed with the leg cut off. It's like you and me. Didn't even expect it, didn't even plan for it. And they're able to help each other get back and challenge each other in life. And then, so our work, through all these competitions and all of that, our work has been featured on Star Sports, History Channel, Hindu, so on and so forth. And even companies have been coming and helping us, supporting our work through CSR, be it with Mercedes-Benz or Aditya Birla. It's been a huge honor. We filed patents, so on and so forth. And then with the word going out, a lot of people started coming to us. And then again, as an engineer, it really bothered me as to how qualitative the aspect of making these devices were. Case in point being, this is traditionally how it's done. The patient has to travel to a workshop. They get this plaster of Paris casting, and then you take that cast, it has to set, then you pour plaster of Paris, and then you have to qualitatively carve away. It's very artisanal or artistic. And the problem was, you go with one amputee to this medical guy who does it. His name is, he's a prosthetist by training. You go to one amputee goes to 5 prosthetists. They'll take these impressions and do their own modifications, and you'll end up with 5 different designs. And it drove me up the wall. How qualitative could it be, especially when there is a science to it? There has to be a methodology, rigorous methodology. It can't be artisanal. So we developed a digital fabrication framework with which it is highly parametric and repeatable. So basically, we've developed a 3D scanner where you take the scanner of the patient, digitally modified, and you can CNC carve it off. And then what would take days to make, or weeks, on an average, it would take 3 to 4 weeks to make a device. We can now do it in about 1.5 to 2 hours. Extremely precise, extremely repeatable. Be it, of course, there was a lot of innovation in developing a high-density foam, so on and so forth, and all of that. So now, with this digital fabrication framework, we can not just make prosthetic legs, but the whole body, be it cranial orthotics for kids with epilepsy, cerebral palsy, spinal orthotics, people with spina bifida or scoliosis, kyphosis, hand and leg. And the same technology can be used not only for assistive devices, but even to prevent work and sports injuries, or even going into the other end of the spectrum for performance aids. Basically making wearable bionics affordable and accessible to people. Now, with all of this, one of the challenges we had was, again, this is about trying to build a great company that is technologically driven and powered. And we started off with this cane prosthesis that is lightweight and flexible. One of the interesting things that happened was we would get so many patients that again, this is a natural cane. It has its own variances because as a natural product, it's some of it is good, some of it is not medically approvable from us, that we would reject about 70% of the cane of this one particular species, which is proprietary to us, or rather we haven't disclosed, it's a trade secret to us, that it was such a tragedy that all that cane was going to waste. So then what we did is, though it was still very good quality cane, it's just not what we call medical grade. Instead of making that go waste, with the engineers and designers that we have on staff, we created art that can be used with the medically rejected cane to make large installations that can be sold at a premium. And we use this funds to subsidize the research and the medical devices. So we've made, this is all done by our absolute genius designer, Sanjay Kumar from NID Ahmedabad, made of, in fact, there was a lot of joinery and innovation that we've developed that was inspired from the solutions that we created from the medical devices that we created. And in turn, we developed, like even the joineries in this chandelier, we wanted Sanjay wanted a hook that could not only take the weight of these buds, but it had to also slide up and down, forward and backward. It had to slide forward and backward, take the weight of the bud, but also pass power through it. That is a tricky joinery. And it was, in fact, using a design that we use for our medical devices. We were able to make the appropriate joinery for this chandelier, and again, fusing multiple materials. So this has been a journey of not just technology, but about inspiring people to get back at life. And through art, it is, in fact, art as a business that can fund innovation in the medical space so that we can do social good and in turn create more opportunities for artists to create art and creating one positive upward cycle. So that is briefly our journey here at Rise. The company's name is Ray Rise Design Lab. We are a design lab, and we started off with making prosthetic legs, but now we do it for the entire body. And yeah, that's briefly my story about how we go about, making what we do. And I would now like to open this to open the floor to people. Thank you very much.
Thank you, sir. Thank you. Now the Q&A session is started. You can ask your questions in the chat box. Use the chat box to post your question.
So while people are, while people are thinking about a question to ask, again, the whole idea is about, especially as IITians, I encourage you to use technology as a tool and not lose focus of who you're doing this or why you're doing this. Technology at the end of the day is a tool that that enables or provides opportunity to do good. There's a whole other matter to it about how technology needs to be regulated, so on and so forth, and all of that. But those are all other matters. But again, especially in my world, in the field of medical, it's about getting, for me, again, even as a robotics engineer, at the end of the day, it's about people and helping them get back to life. And this whole 3D, the digital scanning and fabrication, and this whole using Keen as a natural composite, that's about, what should I say, enabling people.
Yes, sir.
Is there any harmful effects of this? Well, objectively, that's a good question. So nothing is perfect. Everything has its pros and cons. And this is exactly what I was talking about. Things need to be regulated, right? So now, one of our biggest concerns was scanning, zero problems with scanning. It's just infrared-based scanner, zero problems. If I was telling you about the high density foam that we create in which we carve. If we were 3D printing it, it would take about 10 to 12 hours to print something the size of a socket, let alone even if it was strong enough or even economical enough to even print. So we didn't go the 3D printing route because honestly, the materials are not strong enough that are affordable and accessible. Sure, we can 3D print with metal and all that, but that's extremely cost prohibitive at this point in time. So it's definitely the future, not today. But we went this route of using this high density foam. I'm not disclosing the details of the foam because that's proprietary, but we wanted, when we carve it, there's a lot of waste foam. And one of the questions my mentors asked me is, what are you doing about the waste foam? What are you taking care? Are you just dumping it, getting rid of it? So then we decided a way to recycle that foam we carve. And mind you, when 3D printing would take about 10 to 12 hours, this carving of the foam takes about 8 to 12 minutes, 8 to 10 minutes of carving. That is how we can do from scan to fitting in about 1.5 hours. So we figured out a way to even recycle the foam 100%. So that's how I feel. There is honestly no harmful effects that I am aware of, but we are working towards almost going down to zero waste. And again, as I was telling you about, even the waste cane, upcycling that to make furniture and art is one way we can bring it down to zero waste, right? So I hope that answers that question. Thank you for the questions coming in. You changed a mainstream career. How many ideas were there that actually worked? And how did, Swaraj, I know what you're talking about. How many ideas were there that actually worked? If I can be candid, every idea is somewhere on the shitty spectrum, okay? Nothing is perfect. And I'm an automotive guy by training. Okay, I worked at DC Design, and I could just hear an engine. I could tell you what car that is. The Porsche 911 today is like the standard benchmark on which other cars are evaluated. It is such a good car, but it is textbook wrong car to have been designed and made. Textbook wrong car. The engine, instead of being mid-engine, it's a rear engine mount. The weight distribution, it's just a terrible textbook car. But the Germans, they have just over decades perfected, corrected the design that it is today the benchmark. And I am a strong believer of that philosophy, wherein there is an idea, nothing is perfect, you have to just be perseverant, you have to be tenacious in just improving it. But that being said, philosophically, you need to be objective about it. If it's a shitty idea, cut your losses, move on. So, but then if you can see there is reasonable scope for improvement, then give it a shot. And honestly, I didn't expect this company to have survived so many years. I just gave myself 6 months to work on this idea. And if it was going to fail, sure, no problem. But at least I tried. But then it was always something that I was able to solve. And then 6 years on, serving having been cleared by the Indian Army, having been presented to other countries by the Ministry of External Affairs of India, having worked with so many organizations, it works. It's about, it's about making things happen. When you find a team, everyone can tell you why this is not going to work. It's too easy. It's about finding a team who can help you figure it out, how you can make it work. But at the same time, I also there's a caveat about don't beat a horse to death. If it's a bad idea, cut it loose, move on, pivot. So, and how did you handle the pressure? To me, and I think this is extremely appropriate to you IITians, for me, doing this tech company has been more of a personal and a philosophical journey about me, myself, than about a technical or a business endeavor. Like the monsters that I see in myself about how, this has been honestly more of a personal journey about my weaknesses, my vulnerabilities, than the technical challenges. It's about, again, if you are taking on an idea that is bigger than you or that is big enough to be solved, I can guarantee you will never have all the answers to it. But finding people that are smarter than you can help you figure out the answers to the challenge you have. Like case in point being, the artisan. I was telling you about the cane artisan. There are 1,200 different species of cane. And he told me, look into this. He is an illiterate person. He's not received an education, but he is a gem of a character, gem of a person, a wonderful husband, a wonderful father, just so knowledgeable that his knowledge is priceless. And it is only through him I was able to do this. Otherwise, where do I have the means and resources as a student to test 1,200 different species? So it's about working with people way smarter than you. Yeah. So apart from the value part, is Amit, that's a good question. Is the business of prosthetics profitable? The short answer is yes, it is. The margins are solid. My bigger concern is about the market size for now. Look, Rise is not going to be a multi-billion-dollar company wherein like Facebook and Google. We're not. But is there a need for it? And honestly, I love doing what I'm doing because not only is it at the intersection of various domains like computer, mechanical, medical, artisanal like carpentry, it is so fun. And the challenges that we face day in, day out, handling people, new patients and all that, phenomenal. So I love what I'm doing. Is it profitable? I mean, absolutely. Again, tricky because we build, unlike any other organization in India when it comes to prosthetics, they are only aggregators. They'll buy stuff from China, Turkey, Taiwan, wherever. package it, assemble it, and then sell it up. But we manufacture this in-house. So therefore, so we are a highly vertically integrated company. Therefore, we don't have middlemen to pay, and therefore our value is, our prices, our cost is significantly lesser than that of competition. Doctors have said that our price is about 50 to 30%, no, 50 to 70% less than that of competition. So now we are actually increasing our prices just so that we can be perceived as quality, So, see, so then that's about, again, lean manufacturing, lean business or a lean organization structure. And it's honestly really fun. It's extremely challenging personally, if I may say, to figure all this out. But then again, get a smart team, they'll be able to help you through this. And again, for me, this is about building a great company. And to build a great company, it's like they talk about the triple bottom line, right? That is people, profit, planet, right? So it's about it's about genuinely taking care of your customers, team, and investors. There has to be a solid value proposition. So that is people, profit. Profit, I mean, because we are highly vertically integrated, we don't have middlemen to pay. It is, there is a huge value proposition in this. And then planet, recycling the material, upcycling our waste. That's how we are trying to do it. It's still a work in progress. There are more than 100 things that we can improve in the company. We are chipping away at it step by step, right? Good question. Somebody asked which material is used there. If you can articulate your question more, because as I said, we use a lot of materials from cane to the foam. Exactly which foam that is again proprietary. That is a trade secret. Okay. Priyanshu, first of all, very proud that you're doing initiative. How long does it take for an amputee to get these prosthetic legs installed? Thank you for the compliment, Priyanshu. As I was saying, usually in the industry, it takes about 3 to 5 weeks for a customized prosthetic leg. Unfortunately, a lot of organizations give free devices that are prefabricated, and it's never fitting the person properly. And the free and the prefabricated ones, it's almost ready. They'll fit it in a few hours. But then because it's not fitting properly, it will hurt the patient. And that will lead to complications and possibly even secondary amputation. So for customized solutions, the average is about 3 to 4 weeks. 3 to 4 weeks. If we go guns blazing, 1.5 to 2 hours. But otherwise, if we just chill about it, in a day or two, we deliver it to patients without charging premium. Thank you for the compliment. What are you using so that it does not hurt the human? Standard medical grade materials. We've done multi-center clinical trials, be it with hospitals like CMC Vellore St. John's Hospital and with the Indian Army. So none of it is, what should I say, anything that interfaces with the human body is medical grade. No two ways about it. And then also, what should I say? I just want to extend that question to saying that what we do is, and again, a point to coming up engineers is, as engineers, as students, the heavens open up when our prototype is working. Yes, it's working. But ladies and gentlemen, that is step one of the journey. You have to, it should be designed for manufacturability. Please, I would encourage you, go to the machine shop or make stuff, learn the challenges of making, because anybody can design something in a CAD model, but then you give that to the machine shop guy and he will tell you whether that was designed by somebody who knows machining or somebody who only knows CAD, because anybody can put a hole on multiple surfaces, but then only if you're machining do you know how hard it is to reorient and then re-zero. But if you knew how complicated it was and that was going to cost in rising cost in machining time, you would redesign it so that it's all in line or in the same phase. It's easy to machine. So all I was coming around to say is design for manufacturing. designed for assembly, designed for serviceability, and the most important is you have to design it for failure, or rather safe failure. If it fails, it has to fail safely. And that is something that I'm really proud of for such a natural material like cane. That is, when carbon fiber, which is an engineered composite, when it fails, it will catastrophically fail. Meaning, if there is a slight hairline fracture on impact or whatnot, it will just explode. Cane, on the other hand, it yields. It does not catastrophically fail. It will, just like aluminum, it will start yielding and compress. So even if it fails, it is designed to fail safely. Yeah. So, do multi-center clinical trials, so on and so forth. How can you make it more feasible so that it's affordable to the poor? Again, what I'm really happy is not only have we done our pricing such that this is something somebody asked earlier too. I want to add this response. What I'm really happy as the founder of the company is we will have a person drive an auto into our clinic, and right after that, and because it happened, right after that, you'll have somebody in a Jaguar or a Mercedes GLS Jeep coming in to get fitted at our facility. We treat everyone equally. Everyone has access to the same option of devices, and then by virtue of, what should I say, our pricing structure and portfolio of devices, something unexpected, because we are a company, something so unexpected was the patrons that are well off. They said, you know what, if there is somebody that can't afford your devices, just let me know, and we'll be happy to help out. So it is our older patients or other patients helping out the newer ones. And I tell them, look, we are a company, there is no invoice, sorry, there is no tax deductible. We don't have an ATG and all of that. So they're like, no problem, just give me the bill. And we give them the invoice and they pay for it. So that way it's affordable to the poor. That's what we do. Where did you get the motivation to start Rise Legs? Ashwini, thank you for that question. Honestly, I have the honor to work with people, one of the like really smart people, be it from Harvard, MIT, Berkeley, Columbia, and I worked on personally a lot of cool projects, be it for the US Department of Defense, so many other cool projects that cost like literally crores of rupees, like robots that could swim in water like a water snake, come onto land and walk on four legs, and surveillance the beach and all of that stuff. And it would help maybe the military, or maybe again even the medical stuff that I worked in the US. It would help a few people, but then I came down to India to help my little sister with her wedding, and it was a curiosity question, as I mentioned earlier, and I did not, honestly, I didn't expect to do this company. It was just one thing that naturally led to another. As I said earlier, I only gave myself 6 months, and it's been 6 years now, and I'm still doing this. We are from in the beginning, I was just doing this out of my friends helping me out and then giving me money, because what money do I have? And then when History Channel and BBC and Star Sports did some documentaries on us, people started coming, and I was like, oh my, I can't make so many free stuff. I don't have so much of people helping me out. And then when I asked people to at least pay for the devices or the cost of devices, one of them asked me for a bill, for an invoice, and I was like, oh boy, And then back in the day, I then had to do a proprietorship so that I could put the VAT or the TIN number. So that's when I went and then created the proprietorship, and then I did that for about 4 years or something like that. Developed this whole digital fabrication, and then when I realized, okay, there is so much I can do, and now I need other people's investment so that I can now put this all under one roof, because otherwise, just to make one leg, I would go to this one machine in one part of Bangalore, then I would take it to another part of Bangalore, from Pioneer to Jigni and all of that. It would take me like hours just traveling to get access to these machines. Now, if I needed all those machines under one roof, I need professional investment, and that's how I started the company, and that's where we are right now. Um, okay, how effective can these be with respect to normal legs? Are there any, yeah, and is it affordable? Sonali, good question. Let me be very clear and candid. A prosthetic leg is never going to be as good as a natural leg. Never. It's never going to be. So we're very clear about that with our customers and patients. We're not trying to give them any false hope, but it is good. It's good enough to get back to life. Um, in fact, what's very interesting is that the average, now when you look at the Paralympics, the average um, race time for the 100-meter sprint, the average time for the 100-meter sprint is far higher than the Olympics. How about that? That is, these prosthetic legs, people are able to run faster than normal people, that the average race time for a Paralympic 100-meter race is faster than that of a normal Olympic race. So, that's interesting. Again, with deep science, again, this is all about bio-inspired design, wherein you understand, you look at nature, break it down to mathematical principles. It's not about just having a joint, but rather understanding that the human leg is a spring of tuned stiffness. It's not that it has 5 toes and an ankle joint and a knee joint, but effectively it's a spring of tuned stiffness. And people have replicated that spring stiffness with composite like carbon fiber. And you have that J-shaped leg or the cheetah leg or whatever people call it. That is effectively a compliant spring of tuned stiffness. So with deep science know-how, you're able to make things, and then with wearable exoskeletal suits, we are well on track to getting back at life and more. Are there any disadvantages? Is it affordable? What we do, yes. Yes, Shashi. So, can this service be extended to animals, and would it be feasible to provide prosthetic for free to animals? We've had people wanting to help out cows in gaushalas and all that reach out to us. Absolutely, it can be, with the right structure. Yes, it has been done. It has been done. We can help animals, absolutely, and that's really dear to me too. Rishita, how could one design a prosthetic leg for a para athlete, keeping in mind its necessity and comfort? As mentioned, Paralympic Sumit, he faces certain issues with prosthetic legs while throwing the javelin. Um, yeah, good question. So, what we've just started, what we do, and honestly, we've done zero marketing. This is, there is, uh, ladies and gentlemen, this is such an underlooked industry that we need people like you and me to come in and make a difference over here. There is so much I can do. I'm trying my best, and I haven't really taken in too much of money, and I don't have the time to do. I haven't really done very much marketing. So yes, there are a bazillion ways that we could help Paralympians, to be great at what they do. We need, in fact, the ecosystem, the infrastructure to even help this, not just as from an athletic point of view, but even the superstructure of supporting the ecosystem, be it getting in companies, building the connections and all of that stuff. So it's, again, ladies and gentlemen, it's not just the technicality of the design, but this is where I want to encourage you all in ensuring the superstructure to ensure good innovation is also happening. Are you following me on that? Uh, like, in terms of helping Sumit to throw the javelin, if we can work together, if there is an ecosystem environment where we can be brought, people like me, there are so many other people also, but not enough, not nearly enough people who are technically competent to do this. There are a lot of quacks, unfortunately. So we need good people to come in. There is so much, and there is a lot of money to be made in this. No two ways about it. No two ways about it. Especially when you look at not just in the disability sector, but you look at work and sports injuries and even performance aids. There is a lot of money to be made because it's really untapped here. Let alone in India, world over too. I'll tell you that. So you know, uh, come join. There's so much to do. Yeah, Akshay, will it be taken forward? Is your idea for prosthetics, will it be taken forward and try to build superhuman-like abilities? Um, so at Berkeley, we developed at the Human Engineering Lab under Professor Humayun Kazruni, an absolute wonderful visionary person. He started two companies called Exo Bionics, EKSO Bionics, and SuitX. And Exo Bionics made and makes wearable exoskeletal suits for the special forces, wherein they could carry 80 kgs of load and run faster than able-bodied people. It's called the Hulk, Human Universal Load Carrier, HULC. Um, I mean, it's no Iron Man, but it is made up of cast titanium with hydraulics and all that. Damn cool, damn cool. Check it out, HULC EKSO Bionics, and in fact, my other startup that I have the honor to work with very early on, SuitX, they got acquired by a multi-billion-dollar German company called Autobock. They make passive wearable exoskeletal suits. It's used in the industries and all of that stuff. So uh, nowhere near what we see in the Hollywood movies, but never say never. You know, it'll. I'll tell you one thing. Things in the labs, especially in the US, they are about 15 to 20 years ahead of what you see in the markets today. 15 to 20 years ahead, they are what you see today. So it's crazy what happens in these labs. Can this technology be useful in other external parts of in the future? Are you willing to expand the technology to other fields too? Yeah, I mean, we're already doing it. As I said, we're doing it from, that is current Saxena's question. We're absolutely doing it for what should I say, from cranial helmets, spine, hand and leg prosthetics, orthotics, all, the whole body, we do it. And there is so much more that can be done. So, Karan, please hit us up, and then we'll be happy to help. You know, there's so much more that can be done. I'm sorry, my company, the thing just jumped. Where are we? Yeah, okay, Swaraj. I've been thinking how incredible your team and research have been. Would you like to share some interesting experiences at work that are memorable? Yes, Swaraj. This is hard work, okay? Very hard work. It's really hard. Too many times I ask myself, why am I doing this? Because it's, trying to do all of this, it's telling, as I said, it's more of a personal journey than a technical and a philosophy, than a business journey. Not technical, not business, personal journey. And usually when customers call me, it's when things go wrong. We really feel we are like the traffic police. Every time the traffic police talks to somebody, it's when they've done something wrong, So when the device is not working right, or it's not fitting right, or, their body has changed shape, when things are not right, that's when they call. So I was in the middle of Commercial Street, which is in Bangalore, at about 7, 8 p.m., searching for something, for a piece. And that's one of the biggest challenges here in India. You need to go to these stores and talk to people, and they will tell you, because nothing's not the real detail, good stuff is not on the web here in Bangalore. So we have to go to, it's at 8 p.m. and I was just in the middle of the street searching for something I couldn't find. I was so tired and frustrated, and I get a call from this customer, 60-year-old person from another state, and I was like, oh my Lord, I'm going to, what now? And I didn't want to take the call, but I was like, it is what it is, take the call. He had just taken a leg from us, and he's 60 years old. He was using an American prosthetic leg for the past 6 years of his life. And because it was this fragile silicone, he always had to wear a shoe. And ours is designed so that you don't have to wear a shoe, so you can walk barefoot, you can enter the temples and all of that stuff. It was Diwali the previous day, and he just called to say that for the first time after his amputation, he was able to enter the temple with his wife, and he just got out of it, and he called to say thank you. And it's moments like these that really help me or give me the strength to do what I'm doing. It is otherwise, I can give you 1,000 reasons why not to do what I'm doing, but it's moments like these, Amra's case, Amra or Samira's case, like her parents, um, they were very happy and thankful, and and that you're using technology. I'm a technologist by training, and I love to use. But then when you see the human element in it, when you see that you're helping people, there's nothing like it. So there are so many stories I can tell you. Yeah. Do you think there would be any future inventions that can? So Shalini, your question is, any future inventions like this that can replace a prosthetic leg? Of course, this is just a moment in time. Um, so like even now we have like osseointegration where prosthetic legs are in fact integrated to the bone, and brilliant work done so that there is no infection and all of that. Then there is stem cell therapy and all of that stuff, or where people are looking to regeneration of limbs and all that. So that's definitely the future. Um, It'll be, in fact, interestingly enough, we would be very successful if nobody ever needs a prosthetic leg again, in the sense, case in point being, so we're going into even prevention because diabetics is the largest cause of amputation, going into diabetic prevention kind of, and then if nobody ever needs a prosthetic leg again, that's when we would truly be successful. Yeah, and somehow profitable? It is not somehow profitable. It is profitable. No two ways about it. For it to be a viable, sustainable company, it truly is. Do you think a new generation will take over this one? Please. It's a matter of due process and due time that something better will always. It's inevitable. Change is the only constant. So one thing that I strongly believe, we are innovating far ahead of what we are patenting and commercializing. We are way ahead. So, the cane prosthetic leg is one tiny part of what we do. Very tiny. The whole digital fabrication now is way bigger. We make silicone products like the prosthetics that otherwise, silicone liners and diabetic footwear and all that otherwise you had to ship in from Italy and Netherlands and the US. Now we do that in-house. And so the whole point is you can't rest, you can't be complacent. But then again, the point is, are you having fun doing what you're doing? This is not about resting on your laurels, but rather keep having fun. What's the durability of this prosthetic leg? ISO 10328. Anand, the question is, what's the durability? ISO 10328 requires a 2-year lifespan for walking, and technically, when you walk, the loading on your foot is about 1.2 to 1.6 times your body weight. But when you're doing high impact activities, which is not under the provision of ISO, you're loading the leg at about 2.2 to 2.8 times your body weight. Our legs are designed to take in high impact activities, and people have been using it for over 4 years. Now, of course, if people do something silly and stupid, one guy, I kid you not, he shaved off 2 6mm bolts, and we were like, how did you do this? Basically, he's wearing the prosthetic leg, and he wanted to kind of slow down the tractor's wheel. He put his leg inside that to use it as a brake, and then he shaved off. So accounting for human stupidity, our legs last well over the ISO requirement. Absolutely, it is long lasting. Absolutely.
Sorry to interrupt you, sir.
Yeah.
Sir, there might be chance that this meet gets in because it's scheduled only for 5 p.m. That's why only 2 minutes.
Yeah. I mean, I'll take on the question. Is it already 5? I've got.
Yes, only 2 minutes left, sir.
All right, I'll take this. I love the question, so it's my.
Yes, sir. We can proceed. You can take the question, but I just reminded you because if suddenly it gets turned off, then
no worry.
yes, sir. You can continue, sir.
So where is RISE headed in the future to narrow this gap between prosthetics and nature? We're always inspired by nature, so we'll always be behind nature. No two ways about it. We'll always be behind nature. Devanshi. Yes, Sonali, you're welcome. Building such a company, what is the vision to do something which helped mankind, or was it like a huge market, available health tech, entirely different? No, I always wanted to do something useful, and there is a market for it. You got to find the market. We are pivoting from just making disability to, again, with people with disposable income, be it in the work and sports injuries and performance aids. So we're working towards making it, but it's for me, the motivation is about doing something useful. So yeah, can the disabled be fully able after using the prosthetic leg? They can definitely get back to life, others. Yeah, they can get back to life. It's not using the, I mean, people drive against our instructions. People drive bikes, tractors, lorries, do whatever they want. They've literally jumped out of 8 foot high walls. Yeah, so they've done a lot of stuff, crazier stuff than you and I do. So I think with that, that's the end of the question. So, and I think we are just on time too. So thank you all for the questions, and I hope, I put I've put a seed of thought into your mind. This is not about just the technology, but about ask yourself why or who you're really helping. Be powered by that. Yeah.
Yes.
Wonderful people. You can always reach out to us at our website is riselegs.com, riselegs.com. There is an email address and WhatsApp over there. So you can always reach us over there. Ladies and gentlemen, there's a lot of work to be done in this. Please, be awesome at what you do. And please, one last thing, as an engineer or as a technologist, it's not about shoving another solution, but rather genuinely solving the problem. So ask yourself exactly what is the problem that you're trying to solve, and please don't be married to your idea. You might have a shitty idea, but it's about, are you genuinely solving the problem than trying to shove your answer or technology and all of that? So, yeah. Thank you for your time.
Yes. We are extremely delighted to know the technology behind this path, the RiseLab, the company, and what its motivation is, and the innovation which have been done, which will be done in the future. So I'm on the behalf of entire Kshitij team is grateful to you for embarrassing this session. Also, a heartful thank you to the audience for showing your interest throughout the session. Thank you once again, sir, and thank you all the audience.
Thank you, Anil, and thank you, team from IIT Kharagpur, for this opportunity. And I love the questions. It'll be a pleasure to, reconnect later on. Thank you.
Yes, sir. Thank you, sir. And all the audience, do follow us on the Instagram, Facebook, LinkedIn, and Twitter to know such more innovative things. Thank you. Thank you, sir. Also check out the riselegs.com. Thank you, everyone. Thank you.